Welcome to video number 6 in my portfolio theory series, and as promised in this video we're going to look at the feasible set in the two-stock case, and we're going to understand how changing the correlation coefficient has a very significant impact on the nature and shape of the feasible set. Okay, so here we have some data. The variance of x is 16. That means the standard deviation is 4. Variance of y is 25. It means the standard deviation is 5. Correlation coefficient right now between x and y is 0.4. And the mean historical return on x is 7. The mean historical return on y is 17. And down here is that graph. You'll see that point right there is y, and it's at 17 here and at 5 there. This point right here is x, and it's at 4, and go across here, and you would see 7. So just as we predicted, and it's bending backwards, clearly. That means at this point, the derivative of standard deviation of portfolio return with respect to W, the weight, is negative. Okay? In other words, as we change the weight in this security to become something other than 1, which means we're causing the weight in this security to become something greater than 0, the curve bends backwards. Okay, more on that in another video. But the curve bends backwards. The curve bends backwards, which means we can start at this portfolio, and then almost magically, one might say, by adding this higher variance stock, we can end up with a portfolio comprised of both this and this that has less risk than the lower risk security X when we combine X and Y, as well as a higher return. And that's the point. Okay, so right here we see the behavior of the feasible set in the two-stock case when the correlation coefficient is 0.4. Let's set this at the greatest value it could possibly be, 1. And when it's 1, we see we have a straight line there. We have a straight line there. Interesting. This is the only time when the risk, the standard deviation of a portfolio's return, will ever be a simple weighted average of the standard deviations of the returns of the two stocks, right? So this is risk standard deviation 4, this is standard deviation 5, and this straight line implies a simple weighted average for that, and we'll show the algebra of that later. Okay, now I'm going to change the correlation coefficient to its lowest possible value, -1, and we see this, but this data here is, the only thing that's real are these dots. Excel is putting lines between the dots because I'm asking it to, but I'm going to go up here and I'm going to change one of my assumptions as to the weight in X to something a little, and that gives us a better picture of what's going on. And the point is, this curve will actually end up on the horizontal axis. I guess here it's decimal point, 5 zeros, and then 5.00004. Anyhow, that is effectively 0. And so we get this. And you can imagine if you put the one we had before it, there's our triangle. Anything else is in between. Now, we'll notice that the ratio here, I'll create a new cell here. This is going to be equal to the variance of x. I'll take the square root of that to the 0.5 power, and I'll divide it by the variance of y, also raised to the 0.5 power. Okay? And so that's just sigma x divided by sigma y. Here, I'll put it in red. That's just sigma x divided by sigma y. So, look at this. The correlation coefficient here, which now down here in the graph is -1, that's less than the ratio of standard deviation of x to standard deviation of y, and the curve bends backwards. Let's make it minus 0.2. That's still less than 0.8. Curve still bends backwards. Let's make the correlation coefficient 0. Still bends backwards. I'll change this weight now. I don't need it that precise anymore. Let's change it back to 0.5 in the data table here. Now I'll change the correlation coefficient to, I'll change it to 0.7, which is less than 0.8. And we can see that curve still bends back, but let's change the correlation coefficient to 0.8, 0.8. That curve no longer bends back. Look at 0.9. Definitely easier to see that it doesn't bend back. And then, of course, where we started, if the correlation coefficient was 1, you'd have a straight line. And that's the behavior of the feasible set holding var x, var y, return on x, and return on y constant. In other words, just starting with an x and a y stock, and then allowing the correlation coefficient that we assume to be true to change, and then we see what happens to the feasible set. And over here in this part of the spreadsheet, you can see it all in one picture, where here are the values I assume for the correlation coefficient are what you see up here in the, looks like a gray color. This one is minus 0.9, this one is minus 0.5, this is 0, this is 0.5, and this is 1. And this is just showing you the behavior of the feasible set as a consequence of changing the assumption as to the value of the correlation coefficient. And that is pretty valuable information. And that's all for this video. Thank you for watching.